Hello. So until now, we have been training the word-to-vec embedding using our handwritten text and also using readily available text corpus, and we have tested out the performance of the word-to-vector with the similar words, and also we tried out with different words with the different text corpuses, etc. One thing you have noticed that the performance of this word to vec basically depends on the type of the text corpus which you have been used to train that corpus, right? So you can clearly see that for the same word money, this is for the different text corpus, and this is for a different text corpus, and this one for other text corpus. You could see it could be able to predict different contextual words, right? It is not the same in all the text corpus. So basically it is very shortful or very what we can call vigilant, that so the training or the material which you pass for the training of the word to vec, then that will be the performance of that word to vec. So it is not constant. What I am trying to highlight here is, so it is completely entirely dependent on the type of text corpus which you have used to train that word to vec. So in this case, what we have to do in order to get a ultimate or a ultimate performing word to vector or word to vec embedding, then we have to train this with a large number of text corpuses, and we have to train doing it again and again. So this seems to be very tedious, and uh, it also protects that it's not so easy task, right? It's not so simple task to get the large text corpus, and we have to wait that word to vec to learn those things again and again, and with a different and it's not so easy to get those text corpuses readily available. So in this case, we have to look for the other better or the other approaches or the other word embeddings, which can be, which where we can use it directly. That is like we can borrow it directly and use it to our purposes. So one of such thing or one of such word embedding is the glow word vectors or the glow word embeddings. So these glow word embeddings are like pre-trained word embeddings. Like the Stanford University has trained this word embedding based on the large number of word text tokens. Like here you could see that word to vector is generated from 6 billion tokens. That is almost unimaginable chunk of data that is used to train this word embedding. So in this case, what we can do, we can directly use this glow word embeddings to serve our purposes. So you can just have a visit at this website link which I am sharing it over here, so which will be looking in this format. So here they have mentioned the detailed process, like what are all the text corpuses they have used, what are all the things they have done in order to train this word embedding, etc. So what I am trying to do, I am trying to download these two word vectors or the word embeddings are available in their website, and I am going to use that for the purpose of finding out the similarity or the like the similar thing which we have done here. So before that, the word embeddings or the word vectors which they have provided at the website will be in the form of .txt file. So what I'm going to do, I'm going to use this, and I have to pass this to the glow to word embedding. So it's a pre-processing step before using that word to vec or the glow word to vec embedding. Okay, so we are doing that in these three steps. You can just refer to these three steps which I am carried out to convert that .txt file into word embeddings. Then I'm going to initialize that in the model. For that, I'm going to use another utility called as keyed vectors. So these keyed vectors will load this particular glow word embedding after learning these two txt files. So that's what I am trying to do it over here. And now it's time to check it out, the performance of that glow model or the glow word embedding. So the glow model which I'm going to store it here, so that the same model dot more similar word, if I just pass the word king, then it has given me the more generic terms or the more generic contextual neighboring terms for the word king. it is almost with a different scores as well, and also the words are also very different when compared to the word to vec model which I have just generated based on some text corpus over here, right? So this glow word embedding must obviously perform very well because it has been trained on a variety of word text, or the variety of text tokens, that is almost 6 billion word text uh, tokens, so that it has learned various context of this word king, and it could able to predict these are the most neighboring words for the word king. So we can also test this out, one positive and negative scenario which we have tested out before. So if I just want to get the word queen, that is, if I just pass the word woman along with the king and negating out the word man, then I should get the words queen as at the top, right? So you can just notice the score which is given by the glow model, which is almost 0.769. So if we just compare this with the word to vec before, let just me scroll over the top where that word to vec we have just created, or like trained before with this example. Yeah, so here you could see for that previous word to vec model, if I just pass the same woman and king and negating out the man, it has predicted the word queen, though, but with the lowest score, right? It is 0.684 over here, but in the glow model it could able to understand it very well because it is trained on the different contexts as well. So this queen word is appearing with a confidence of 0.76. That's the major key difference, that's the accuracy with the glow model is generated. The glow model is nothing but the glow embedding which is generated by the Stanford University. You can also check it out for the word woman and hero. If we pass that and if we negative out the word man, we should get the heroine as the or the most top occurring word, right? So you can just see this, it has a better score or a highest accuracy when compared to the previously used word to vector. So the general principle of the generation of these word to vectors remains the same. The only thing is it is a improvised version of the word to vec based on the type of data it is fed, or the based on the chunk of data on which it is trained. So we can use these word to vectors, that is glow word to vector, to directly serve our purpose, which I am going to cover in the further sessions.